Hello, ladies and gentlemen. Today we're going to be talking about functions. Functions are relations, and a relation is a set of ordered pairs. Okay, so the different types of relations that you're going to deal with is a table or a table of values. So, like, you might have 1, 2, 3, 4 for your x's, and then 2, 3, 4, 5 for your y's. Another type of relation is a mapping diagram. And a mapping diagram just has numbers on this side. Typically, this side is like the x side. So you'll just have numbers in here, and they will map over to the other side. So you'll have arrows going from one to the other. And then the last thing is a graph. Well, second to last thing is a graph. Okay, so a graph is just a set of ordered pairs. So here's an example of a graph. We've dealt with graphs enough. And then the last thing is an equation. So, like, if you have y equals negative 3x squared plus 7. So all of these are relations and they are functions because each set of the domain only maps to one set in the range. So that's considered a function. So the domain and range, the domain is the set of x values. And the range is the set of y values. So, for example, if we have a set of ordered pairs, we could write a set of ordered pairs as a table. But if you have a set of ordered pairs, the domain is going to be the x values, the set of x values. So that's going to be negative 1, 7, 3, and negative 5. And then your range values, and before I get to the range, typically when you write your domain and range, you want them in order from least to greatest. So we're going to reorder that to be from least to greatest. And then your set of range values is going to be negative 1. And you only write it once, even though it repeats itself. We leave it just as once. We only write it once. 0 and 4. And with a mapping diagram, our domain is the left side. So we've got negative 2, negative 1, 0, 1, and 2. And then our range is the other side. So we've got the set of 0, 1, and 4. Oops. There we go. So when you're looking at a graph, your domain values, typically we write domain and range in interval notation. So your domain for this graph is going to be from left to right. So when we do domain and range, we do left to right, bottom to top. So our leftmost value is negative 3. And because it's got that closed circle, it's going to be a bracket. And it goes to the right forever. So we're going to go to positive infinity. And our range values is from bottom to top. So now we're measuring the height of this point here, this bottommost point, which is going to be at 1, 2, 3, 4, negative 4. And again, that's going to have a bracket. And then it goes up for positive infinity because that graph is going to keep going upward. There is no asymptote or anything stopping it. So a function is a special type of relation in which each element of the domain is paired with exactly one element of the range. So we're going to determine if each of these is a function or not. So what we are looking for is that our x values go to only one y value. It can be all the same y value, but only one x goes to one y. So we have -3 going to -4, -1 goes to -2, 2 goes to 1, and 5 goes to 4. So yes, this is a function. On our mapping diagram next, if we look at -9, it's going to two places. It's going to -2 and it's going to +5. That does not work. I can't be in two places at once, so that is not a function. So we're looking for those repeated x values is what we're looking for. So if I look here, my domain, I have -7, -5, -2, and 0 with no repeating. So that means, yes, this last set is a function. Okay, next thing we're going to talk about is the vertical line test. It's my favorite way to tell if something's a function or not. So with the vertical line test, I'm going to draw on the picture for a minute because usually I do this with a pencil. But since I'm not there, I'm going to draw a bunch of lines on it. So what you're doing is you're taking a vertical line and you're imagining it moving across the graph. So I'm moving across the graph right now with a vertical line on this one. And if it only touches once, it passes, which means, yes, it is a function. Okay? For example, on this next graph, if I draw a vertical line here, it touches twice, which means it fails and it's not a function. And on our next one, if I draw my vertical lines, I'm only technically touching once at any given point, okay? So yes, that is a function. So you're looking for when you have two parts of your graph stacked vertically. Okay, next thing we're going to do is evaluate each function for the given value. Sometimes the value is just a number, sometimes it's not a number. So for this one, we're going to plug in f of -5. So all we're going to do is take out the x's and put in -5. So we're going to get, that's the next page. Here we go. Sorry about that. So we're going to get -5 squared minus 6 times -5 plus 23. So using order of operations, we're going to do -5 squared first, which is 25. Then I'm also going to do -6 times -5 in this step, which is +30. And then we write the plus 23. And then we're going to add all those, and we get 78. So that's my answer to that one. Next one's a little bit more complicated. So we're plugging in an expression. So we're not plugging in just a single number. We're plugging in 9 minus x. So we're going to have 7 minus, and we always put what we substitute in parentheses. So we have 9 minus x squared. Okay, so what that means is we are doing 7 minus 9 minus x times 9 minus x. So when we FOIL that, we're going to get 7 minus, so when we FOIL in combined like terms, I should say, we're going to get 7 minus 81 minus 18x plus x squared. So then we have to distribute the negative and all of that. So we're going to distribute the negative, so we get minus 81 plus 18x plus x squared. And then we combine our like terms, which are 7 minus 81, which is going to give me -74 plus 18x plus x squared. And that is going to be our answer for that one. So it's not a nice number or anything. It's just, it is what it is. Okay. So next one we're going to do is this one. So we're going to plug in 4. So we're going to get 4 plus 1 over 2 times 4 squared plus 4 times 4 minus 13. So we're going to do 4 plus 1, which is 5, over. So 2 times 4 squared. 4 squared is 16, times 2 is going to be 32. Then 4 times 4 is 16, and we're going to minus 13 from that. So we get 5 over 35, which reduces to 1 over 7. Okay, next one. Looks pretty not bad. So we're going to plug in 4 for x. So we've got 5 times negative 3 to the 4th power. So we're going to do negative 3 to the 4th power, which is 81. So we're going to do 5 times 81, which is 405. And last part is pretty easy. We are going to find the value of x given the y value. So when I say they're giving us the x value, we have to find the y value. I said that backwards. So they're giving us f of 1. So we're going to go to where x is 1 and see where the height of my graph is. The height of my graph is down here at negative 9. Then for the next one, we're going to negative 2. So the value of my graph at that x value is 0. Doesn't go up or down to anything. Then we're going to f of 5. So 1, 2, 3, 4, 5, which is up here, which is at 6. And then 0 is the last one. So 0 is here. We're going to go down here and see what our y value is. And that looks like negative 8. So that's all I have for today. Thanks so much for watching. I hope you have a great day. Bye-bye.